Talk about trig note card 4. We have a coordinate plane, we have the x-axis, we have the y-axis, and then we have some point out here, xy. It has an x value, it has a y value, okay? If I draw an imaginary line from that point down to the x-axis, what this represents is the y value. See, it's the distance from here to here, and since the y-axis is vertical, it represents the y value. If I draw another imaginary line from the origin out to this other imaginary line, this represents the x value, because it's the distance from the origin out to this point on the x-axis, which represents the x value. If I drew a line from the origin to the point, we're going to call this the r value, and we'll be talking about it more as we begin to talk about the unit circle as the days follow along. But right now we're just going to call this r and just accept that it's r. Now, what we're going to be talking about on note card 4 are the 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. And what these trig functions are, they are ratios of the sides of this triangle. And in this case, this is a right triangle because this line from here to here is perpendicular to the x-axis. And so what we have are the definitions for these trig functions. On your note card there, you see that we have the sine of angle theta, which theta is going to be this angle that is created by the x-axis, the initial side, and this r, which becomes the terminal side of this angle. Okay? So sine of theta is equal to y over r. Cosine theta is equal to x over r. Tangent theta is equal to y over x. Cosecant theta is equal to r over y. Secant theta is equal to r over x. Cotangent theta is equal to x over y. I will give you an easier way to memorize what each one of these trig functions are without the y's, r's, and x's. But looking at this triangle, we're going to talk about the ratios of these sides as far as x, y, and r. Okay. Something you might notice right away is that sine and cosecant are reciprocals of each other. We have y over r and r over y. Cosine and secant are reciprocals. Tangent and cotangent are reciprocals. So let's just look at a couple of examples of how we might put this to work. Well, if my point here, looking at example 1, if I knew what that point is, it's going to be, in example 1, 3, 4. Now, if this point is 3, 4, that means the x value is 3, the y value is 4. So that means that this is 3 and y is 4. Now, if I know two sides of a right triangle, I can find the other side by using the Pythagorean Theorem. And I know I'm going to need the other side because I'm looking at the ratios of all these sides. Once I find out what r is, I can tell you what sine, cosine, tangent, cosecant, secant, and cotangent, I can tell you what all of those are. So hopefully we remembered that Pythagorean Theorem is a squared plus b squared is equal to c squared. And in this case, x and y are going to be a and b, and r is going to be c. So I have 3 squared plus 4 squared is equal to r squared. 9 plus 16 is equal to r squared. $25 is equal to r squared, and r is equal to 5 when I take the square root. Now it's plus or minus 5, but we're going to use the positive version in this case. And we'll talk more about positives and negatives as we go along. R is not always going to be, well, R will be positive, but other values can be negative. And we have, right now we're just going to look at the positive version of R. Okay? So if R is 5, I'll just plug that in up here so I can see it easily. That means I can go ahead and find out what all of these values are. The sine of theta is y over r, which is going to be 4 over 5. And since the cosecant is the reciprocal of that, that's going to be 5 over 4. The cosine of theta is x over r, so it's going to be 3 over 5. And since secant is the reciprocal of that, it's going to be the 5 over 3, the reciprocal. Tangent is y over x, which is 4 over 3. And cotangent is the reciprocal of that, which is 3 over 4. Pretty straightforward. Let's look at one more example. Let's say that I have a point on the coordinate plane that maybe doesn't lie in quadrant 1. Let's say my point is over here in quadrant 2, and the point is negative 3, 4. So if I draw these little dotted lines here as I did before, and you're going to want to do this on your paper. The y value is 4, so this side of my right triangle is 4. The x value is negative 3, so this side of my right triangle is negative 3. I need to find r. Well, r squared is equal to x squared plus y squared. So r squared is going to be equal to negative 3 squared plus 4 squared, which is 9 plus 16, which is 25, which means that r, when I take the square root, is still 5. We're still looking at the positive version of r. Okay? Alright, so now if I want to find sine, cosine, tangent, cosecant, secant, and cotangent, when I look at sine theta is still y over r. Go ahead and put 5 there. So that's going to give me 4 over 5. And cosecant theta is still the reciprocal of that, so that's going to be 5 over 4. Cosine theta is still equal to x over r. X is negative 3, r is 5, so this is going to be negative 3 over 5. And secant theta is the reciprocal of cosine, so it's going to be negative 5 over 3. And finally, tangent theta is y over x. So that's going to be 4 over negative 3, or just simply negative 4/3. And since cotangent is the reciprocal of tangent, cotangent theta is going to be negative 3/4. And that's how you find all 6 trig functions when you're given an ordered pair. You have to create that triangle, find r, and just look at the ratios. Hopefully it's pretty simple stuff.